Hello guys, welcome to my class. Today we are going to learn how to design a RCC column. You can design any column of any property. It might a circular column, might a rectangular column. You can design by STAAD Pro by any shape of a column. So let's begin. At first open STAAD Pro. Go to new project, click on space, and you can give a name and you can locate the location. Length will be meter and force will be kilonewton. You can also prefer what you will be suitable for the length and force unit. You can go to inches or pound, any kind of length force unit you can prefer. I am going to design in meter and kilonewton. So then click next, click on add beam, then finish. So I am going to create a beam. Okay, the beam height will be 3 meter as a room. So this 0 to 1 distance is 1 meter, so I am going to create a 3 meter beam. So click on the 0 and click on the 3. Okay, then switch off the snap node, or you can create a node first, as I'm gonna show you. Delete all the things, then go to structure node. Then you're gonna give on x-axis is 0 and on y-axis 0. Okay, you see the node is appear. You can check the node dimension. Node is 0 0 0. Now copy the node by selecting and right click from your mouse, copy the node, and right click from your mouse, paste the node on y-axis upper 3 meter, then okay. Now the beam is created, so column is created. Now add the nodes by add beam. Okay, now this is a column. Now we have to fix the column. So go to support page. You can also give a beam on the column. Okay, for that copy the node, paste the node. The beam will be 3 meter on x-axis 3. Okay, then again create a column. On this support, copy the beam from your keyboard, pressing Ctrl C and pasting for the node, Ctrl V in y-axis, in minus y-axis. So give a minus 3 meter. Okay, you can check the dimension. You think that minus will affect the design, but this is not. Dimension will not give any trouble for the design. The design is based on the support property, member property, and the load. Okay, and check the dimension 3 meter. Okay, remove it and add the nodes by add beam. Okay, now there is 2 column and 1 beam. Okay, now fix the supports. Go to supports here, or you can go to command support specification, fix support. The column is fixed always. Click on add, fixed. Select the support, select the nodes, and assign to selected nodes as if the nodes are selected. Yes, the column has been close. Now we have to give a property. Go to property page, go to define. I'm going to give a circle and a rectangle shape. For your better understanding, you can give any shape: rectangular, T shape, trapezoid, diagonal shape, general. You can design a beam or column, okay, tapered, tube, okay. Circle, the dimension will be 300 millimeter. 300 millimeter. Add, and rectangle 300 millimeter by 300 millimeter. For the beam, rectangle beam, 250 millimeter will be fine, and close. This side is column going to be a circle. Selecting circle and assign to selected beams, assign, okay. For this side, the rectangle property will be given, assign to selected beams, assign selected beams. And for this, select this property, 250 to 250, select the beam and assign to selected beams, okay. You can check the 3D view, okay. This is circular, you can see, and these are rectangulars, okay. Now go to property, load page, go to load case detail, click on add. This is primary load, date load, title name, give a title name, date, click on add, close. Click on the date, click on add, click on self weight, factor will be -1. You can give a nodal load for this node or this node. In the y-axis, the nodal is downward, so minus. Give any value you want, or design the load, give tool parent on, and add, and member load for the beam. You have to remember that the load goes to float to beam, beam to column. So the total beam and float load will be go in the beam column. So give the beam load will also goes the load into the column. So give a load -10 kilonewton, add self weight for the total structure. Click on assign to view. As you view the total structures, assign to view. Click on nodal load and click the nodes by node cursor. So 2 nodes are selected, the load is selected, then click on assign to selected nodes, assign, yes, okay. The loads are given and the uniform load. Click the beam and select the load and assign to selected beams, okay. This also has been given. Now go to command, analyze, perform analyze, okay. Analyze and analyze. There is no error, no warning, so the design is perfect. Then we have to design the RCC. To design RCC, go to design, go to concrete design. You have to select a code. I'm going to select IS456 and select parameters. First clear distance, then compressive strength and yield strength. Okay, so define the parameters. The cover will be 0.025, 25 millimeter. For compressive strength 90,000 kilonewton, and for yield strength 415,000 kilometer. Now select this and click on assign to view. Select FC and assign to view. Select for main, assign to view. Now go to comments. I am going to design beam and also column. Click on add column, click on add. Beam, select the beam and click on assign to selected beams and assign yes. And for column, select all columns by controlling, pressing from your keyboard and click on assign to selected beams and assign beam yes. Okay, all the properties are given. Then again go to command, analyze, perform analyze, okay, and analyze, run analyze, save. You can see there is no error, no warning, so this is perfect. You can go to the output file for values, concrete design. You can see the top reinforcement, bottom reinforcement, all the data are given. Or you can double click for in the beam. You can see that rods, they are given 6 long rod, 12 millimeter size. You can see the deflection, okay, shear bending, loading, property. For the rectangular column, 4 long bars, 12 millimeter bar size. Okay. Then go to post processing. Check the axial force. Clicking here, you can see how it works. Okay. You can see the shear in Y axis and Z axis. This is torsion. You can see the reaction for the columns. Okay. Y direction 25.8 millimeter, and in this column 23.965 millimeter. Okay, so this is how you can design a column. Okay, and you can practice it. Okay. So that's it, and thank you for watching my video.